Next question is xy into 1 plus xy square into dy by dx equals 1. So firstly let us write the standard Bernoulli's equation. So that is dy by dx plus py equals q into y power n. So we have all the terms in the left hand part, so let us simplify that. That is xy 1 plus xy square equals dx by dy. So we are just moving the dy by dx part to the right hand side. So now simplifying, xy plus x square y cube equals dx by dy, right? Now dx by dy minus xy, that equals x square y cube. Now this equation is in the form of linear derivative with respect to x, that is dx by dy plus px equals q. So this is in the form of this equation. So now let us simplify that. That is dividing x square on both the side, we get 1 by x square dx by dy minus x by x square into y, that gives x square y cube. So x and x gets cancelled out. Now 1 by x square dx by dy minus y by x, that equals x square y cube. Now let us take 1 by x as t, 1 by x as t. So that gives, if we differentiate it with respect to y, we are differentiating y because we have dx by dy here. So we differentiate with respect to y, we get minus 1 by x square into dx by dy, that equals dt by dy, right? We need only this part. So moving the minus to the right hand side, so that gives equals minus dt by dy. So let us substitute this, minus dt by dy minus y into t. T is 1 by x, that equals y cube. So next, so we can write, we need to remove the minus sign here. So multiplying minus on both the sides, we get dy plus yt, that equals minus y cube. Now minus y cube. So we have got the reduced linear derivative. So with this we take p as y and q as minus y cube. So now my solution would be t into e power integration p dy integration of q e power p dy into dy plus c, right? So let us take this part now, e power integration p dy, that would be e power integration p is nothing but y, so y into dy, that would be e power y square by 2 plus c. So now let us write this here. That gives integration of q is minus y cube into e power y square by 2 plus c. So the simplification of this becomes very complex. So let us do it by substitution method. That is, let us take y square by 2 as u, again a random variable for our convenience. And now let us differentiate with respect to y. That becomes 1 by 2 into 2y into dy, that equals du. So 2 gets cancelled out, so y into dy will be du. Now let us substitute that. That becomes t into e power y square by 2 that equals minus, because we have minus y cube, so let us take minus out. So y cube can be written as y into y square, y into y square, y cube can be written as y into y square. So we got to know that y into dy is du, so we can write y into dy as du into y square, as y square can be written as 2u into 2u into e power u into du we have already written, right? So there's nothing, plus c. Now minus 2 is constant, so u into du to eu, so plus c, that is minus 2 into u eu into du. We have learnt about integration by parts. That is, for example, if I take the same into u into e power u, that is u into integration of e power u plus u dash, that is derivative of u into double integration of e power u plus so on. It goes on, right, until we get the derivative constant. So here we take u as constant because derivative of u becomes 1. So then we can take minus 2 into integration of u into eu can be written as u into integration of eu, that is eu plus differentiation of u is 1 into double integration of eu. We have already done one integration of eu is eu itself. Again, if you integrate, it will be the same. So 2 into u plus c, so plus c. So u, we have taken u as y square by 2. U we have taken as y square by 2. So again we can take eu as common, right? So eu, if we take, so this becomes u, we need plus, so again we will write minus 1, so that this becomes plus here. So plus c, and if we substitute u, y square by 2 into y square by 2 minus 1 plus c. So the final equation would be, the final answer would be t into e power y square by 2, that equals minus 2 ey square by 2 into y square by 2 minus 1 plus c. If we substitute what is t, x 1 by x, so that is y square by 2 by x, that equals minus 2 e power y squared by 2 into y squared by 2 minus 1 plus c. So this would be the final answer. Next question is 4xy plus 3y square minus x into dx plus x into x plus 2y into dy equals 0. Now this equation is in the form of m into x plus y into dx plus n x comma y into dy equals 0. So this is in this form, that is exact differential equation. So if we take m, now we can take m as 4xy plus 3y square minus x, and n as x into x plus 2y. Okay, now partially differentiating m with respect to y, that gives 4. X is considered as constant, so 4x plus 6y minus x is 0. Now n would be x square plus 2xy, so partially differentiating with respect to x, so that would be 2x, y will be considered as constant, plus 2y. So now dou m by dou y is not equal to dou n by dou x, right? Because 4x plus 6y is not equal to 2x plus 2y, so we now can say that it is not exact. I'll write it in short form, but please do write it in full forms. So it is not exact. So in order to get the exact solution, let us subtract dou m by dou y minus dou n by dou x. So that gives us 2x plus 4y. Now 2x plus 4y is very close to dou n by dou x, right? So let us divide it with n by n. So that is dou n by dou x is 2 into x plus 2y. Y n is x square plus 2xy. We can take x as common from that, so that gives us x into x plus 2y. So again we can cancel this out, so that gives us 2 by x. Now this is considered as f of x or anything. For your convenience you can write g of x or f of x. Now the integration factor if would be e into integration of f of x into dx. So f of x, we found that it is 2 by x into dx. That gives us 2 is constant, 1 by x is log x, so 2 log x. So that is x square. E power log x is log x, so we have 2 with that, so it's x square. Now multiplying x square both the sides of the question, that is for dx and dy. If we multiply this with for m and y, sorry, m and n, so we get 4x cube y plus 3x square y square minus x cube. This will be my m. My n would be x power 4 plus 2x cube y. Now again partially differentiating m with respect to y, I get 4x cube is constant y plus 3x square into 2y minus x cube is constant, that would give 4x cube plus 6x square y. Now dou n by dou x would give x power 4, that is 4x cube plus 2x cube y, that is 6x square y is constant. So if we see dou n by dou x and dou n by dou y, both are equal now. Both are equal now. So we can say that now it is exact differential equation. We have got the exact differential equation. Now let us find the solution for that. Solution would be integration of Vm into dx plus integration of Vn of only y components from the equation into dy, that equals c. So integration of m is 4x cubed y plus 3x square y square minus x cube into dx whole dx plus integration of n of y components. Now if we see here, we don't have any n y values independently. We have x with along with y, or only we have y, so we can write as n of y as 0, so that equals c. Now if we integrate it, we get x 4y plus x cube y square minus x bar 4 by 4 plus integration of 0 is constant itself 0, that equals c. So this is the sorry so this is the final answer. Next question is x square plus y square plus x into dx plus xy into dy, that equals 0. So again this question is in the form of exact differential equation. So my dx part would be my m and my dy part would be my n. That is m equals x square plus y square plus x, and my n would be x into y. Okay, so x into y. My m, now partially differentiating m with respect to y, dou m by dou y, x is constant here, so that would give 2y plus x is again constant, and partially differentiating n with respect to x, so x into y is a constant. So now we can clearly say that dou m by dou y is not equal to dou n by dou x, hence no exact. And again I'm telling, I'm writing in short forms, please do mention in full forms. Now let us subtract dou m by dou y minus dou n by dou x in order to get the exact form. We are doing the calculation now, so that would give me 2y minus y would be y, and so this y is very close to this part, so that is dou n by dou x. So hence we take n, that is we divide by n by n, so that gives me y by n will be xy, so that gives x and y, when y gets cancelled, so 1 by x, this will be my f of x. So and my integration factor if would be e into integration of f of x into dx, so that would give me e into f of x is 1 by x dx, so that gives e into 1 by x is log x, e power log x, that is x. So multiplying x to both m and n, so that would give x cube plus xy square plus x square, right? X cube plus xy square plus x square, that will be my m, and my n will be x square y. Right, now partially differentiating m with respect to y, so that would give me x cube is constant, so 2xy, and my partially differentiating n with respect to x, so that would give me 2xy is constant. So now dou m by dou x, sorry, dou m by dou y is exactly equal to dou n by dou x, so we can say that we have got exact differential equation. So the solution would be integration of m is x cube plus xy square plus x square. Remember the equation which you have got, that one you need to take, you shouldn't consider the question here. So x cube plus xy square plus x square plus integration of n of y, only the y component should be taken here. So here we don't have any independent y component, so hence we integration of 0 dy, that equals c. So then again integration of x cube will be x bar 4 by 4 plus y square is constant, x square by 2 plus x cube, sorry, no plus here, so this here will be dx, so here x cube by 3, that equals c. So again if we take LCM here, so LCM would be 12, 4 3s are 12, so 4 3s are 12, so this will be 3x bar 4 plus 12 would be 6 times, so 6y square x square plus 4x cube, that equals c. So this will be 3x 4 plus 6y square x square plus 4x cube, that equals 12c. So since c is a constant, 12c will also be a constant. We can consider it as a. A is some random constant. So that is that equals a, a where a equals 12c. Since 12 is also constant, multiplication of constant with another constant would be a constant itself. So I write it as a. So this will be the final answer. Next question is dy by dx plus y cos x plus sin y plus y by sin x plus x cos y plus x equals 0. Now, this directly can't say this is in the form of m of x comma y into dx plus n of x comma y into dy, right? So let us simplify this. Let us cross multiply, that is dy into sin x plus x cos y plus x plus dx would be my dx into y cos x plus sin y plus y equals 0. We got this term by cross multiplying. That is, if we take this to the right hand side, this would be minus. So minus in the sense, if we multiply this, the denominator with the numerator of the left hand side, and we multiply denominator of left hand side part with the numerator of right hand side part. So if we again shift to the left side, it will be plus dx. That's it. Now my m will be this one and my n will be this one now. So let us write dou m by dou y, partial differentiation with respect to y. That will give me cos x plus sin y will be cos y, right? Plus y will be 1, and this one dou n by dou x will be cos x plus x is constant, that is cos y plus 1. So here both the equations are same, so we can say that dou m by dou y exactly equal to dou n by dou x. So equation is exact. Then the solution would be integration of m is cos x y into cos x plus sin y plus y plus integration of constant part of y. We don't have anything, so this will be 0, that equals c. So integration of y is constant, cos x is sin x sin x um sin x plus sin y will be constant into x, integration of 1 will be x, so plus y into y is constant into integration of 1 is x plus integration of 0 is 0 itself, so the no need plus here, so that equals C. So this is the final answer. Remember, here we need to mention dx